Hello, everybody. First of all, thanks for joining us at this webinar today. As you know, we'll be discussing how to avoid a future fuels dead end and how to build an agile strategy. I think it's clear to all of us that the transition to low carbon fuels is a necessity if the marine industry is going to meet the IMO's emissions reduction targets. However, while the list of options remains relatively short, there are numerous feedstocks and production methods for each that impact on their true life cycle carbon intensity. It's confusing, which is why at a time when strategies should be under development, many ship owners and operators are struggling to understand where to start. That said, because of the timeframes, decision making needs to start now, despite the uncertainty. So to help provide some support and direction, our panel will explore what should be considered when putting together an emissions reduction strategy to ensure that vessels will be competitive in 2030 and how to ensure they remain agile and adaptable as the future landscape evolves. So without further ado, let me introduce you to our panel. I'm joined by David Pugh, Principal Marine Engineer at Houlder, Chester Lewis, Managing Consultant and Maritime Lead at E4tech, Mark Cameron, Chief Operating Officer at Ardmore Shipping, and Sebastiaan Bleuanus, General Manager, Research Coordination and Funding at Wärtsilä Marine Power. One quick thing just before we start, please do submit your questions through the Q&A function, which should be evident on the right-hand side of your screen. We'll put a selection of them to the panel after the main discussion. Chester, start with you, if I may. I wonder if you can sort of set the scene for us in terms of regulation and how the supply chain for future fuels is building out.
Yeah, sure, Amie. I'll give it my best go in a couple of minutes. So, I think the first thing to really start with is sort of the drivers for why we're talking about moving to decarbonizing the maritime sector. And you mentioned one of them being the big one, regulation. But the second one there, which is often not talked about as much in terms of decarbonisation, but I think is becoming really important, which is the sort of consumer drive for decarbonisation, and therefore the impact that has on supply chains of manufacturers and distribution, stuff like that. So I think there's a big drive in the sort of corporate sustainability world to also reduce the scope of emissions, particularly in the supply chain, which is also affecting the maritime sector. But in terms of regulation, we obviously have lots of well-known regulation now at the International Maritime Organization level, looking to decarbonize and setting targets for 2050 and even carbon intensity targets for 2030, which impacts international shipping. But we also have the domestic level policy and regulation that's really starting to impact. And I think the example you can use there is the UK bringing all of their shipping, so not just their domestic shipping, but their international shipping within their legally binding net zero target by 2050. So there's definitely a big push on the regulation side, and also, like as I said, the corporate sustainability side for this transition to happen. And much of that feeds into your introduction. Just on the supply chain side, I think it's firstly good to sort of recognize that we are at the start of the supply chain building out, and also good to recognize that maritime is not alone. Maritime's decarbonisation story has probably started fairly recently compared to other sectors, but the supply chain for a lot of the fuels that we talked about is also being developed for other sectors as well. We'll come on to it, but I think the supply chains are at various levels depending on the fuels you can take into consideration, and also the types of fuels can also be produced in many different ways. So it's a thing that we go into a lot as E4tech, is looking, an LNG can be produced from fossil sources, can be produced from a biosource, but also can be produced from electricity in combination with a renewable source of CO2. So all of these different supply chains are at different levels of technology maturity, of commercialization, but they're all sort of marching forward at different levels. And it's really, I think, now trying to match up the demand from the shipping sector with the supply and the demand from other sectors to make sure we can move those supply chains forward as quickly as possible. But as you indicated, there's a lot of uncertainty about which ones are the best, what are the costs, the sustainability characteristics of all these different routes, and hopefully that's what we'll try to dig into a little bit today.
Thank you. That's really helpful. Mark, I think it'd be sensible probably to start with you. There is so much uncertainty, but decisions need to start being made, don't they? And how do you plan for the future? How do you safeguard flexibility but still make progress that starts today?
Good questions, and not sure I have a simple one-line answer, but let me start by saying that the 2030 countdown is on, and it's been on for some time. And in reality, we're already in 2022. So, 2030 is 8 years away, of which, if you're only in the planning stage now, you've really only got, let's say, about 7 years left. That's a pretty short time frame. When you consider how long a typical asset like a ship is in commercial operation, that's arguably somewhere around a third of its life. Chester's right around the consumer-based approach, and I think we're certainly seeing that where we are active in the tanker sector. And it has been reported that recently a vessel was dropped on a fixture because of its environmental scoring, and that's indicative of a significant change in the chartering world, where in the past it was always the lowest price won the fixture. So if that is, as we believe, a true indicator, then certainly our customer base is moving towards a more balanced view of the assets that they're using, and we welcome that. Just to pick up also on what Chester said there about the legally binding approach, and I think the maritime industry, although we do have targets from the IMO in this respect, we are very much legally bound by everything that we do in the way that we operate the vessels. And certainly with EEXI and AER and CII coming in, these are written into our operating constitution, if you like. So by that sense, they are legally binding. The maritime decarbonization has been around for a while, and certainly in my own business and in our interactions with our financiers, going back to 11 years when we started the business, eco was a very common term that was used back then. You don't hear of that too much anymore, but I was certainly very keen to point out that eco is not just economical, it is also ecological. And I think that was often a term that was misunderstood when we talked about assets being eco-oriented. The ecological side is a function of being economical. And we should make sure that those two terms are interswitchable. I don't believe that the future fuel strategy is a dead end. I think that the future fuel strategy that we've got is an evolving world, and anything that you're doing in this area should be a welcome move in the right direction. So I am very much a supporter of doing things. And one of the areas that I'm particularly focused on is diesel generators, because I think the electrical load on board vessels is the low-hanging fruit right now. And you can get some pretty good savings on an electrical load basis by looking at alternative forms of fuel. And hopefully we'll have the opportunity to expand a little bit more on that in this session.
Thanks, Mark. Sebastiaan, perhaps you can share some thoughts on that. I mean, that's, ecological, economical. Efficiency is also presumably as important as flexibility. What are your thoughts from your perspective at Wärtsilä?
Yeah, thanks, Amie. It actually is. So one of the key things to avoid a future fuels dead end, and I think it's Chester that already mentioned this, is flexibility. So trying to build in flexibility in new build vessels already today. So maybe not installing all of the componentry that you would need to run on a certain alternative fuel in the future, but making sure that you can if you want to or if you need to. But aside from all of the talk and all of the discussion about sustainable fuels and future fuels, we need to remember indeed that efficiency is king, and we as an industry have always been very efficiency driven. But if you look at efficiency, and with efficiency I broadly mean all of the technologies, all of the operational practices that allow you to conduct the same operation whilst utilizing less fuel. So that's my definition of efficiency. But if you look at that kind of efficiency through the lens of future sustainable fuels, one thing we know for sure is those fuels will be more expensive than what we utilize today, by a factor of 3, 4, 5 maybe. Let's assume factor 3. But that means that efficient technology or efficiency enhancing technology in operations, because it's both, it's more than just technology obviously, is also going to be worth 3 times more than what it is today. So when making investment decisions about efficiency enhancing technologies or operation, keep in mind that the investment you make now will also need to be compatible with the sustainable fuels, i.e. its value should also be looked at through the lens of the cost of future fuels being roughly 3 times of what we use it today. So from that perspective, efficiency is basically a no regret option.
Indeed, it makes every sense. And David, I'm give us sort of your thoughts. What are you seeing? How things are, the organisations that you're working with? Does this all stack up? Does it mirror what you're seeing? How progress is being made?
Yes, I think it absolutely stacks up. And Sebastiaan makes a very good point. Is the efficiency has been a driver for a long time, but the economics around the changes and the features which you're designing into vessels, or the technology you're willing to refit onto existing ships, doesn't just need to stack up economically with today's fuel prices, but needs to look at what the fuel prices are going to be in 5, 10, 15 years, depending on the life of the asset that you're looking at. And that can shift what technologies become economically viable, as well as ecologically better for the planet. So I absolutely agree with what Sebastiaan said, and the flexibilities as well, given the supply chain development that's going on at the moment, with the different fuels being at different levels, depending on the technologies that you're looking at, some may have a greater degree of uncertainty in the supply chain, and then flexibility becomes more important, whereas others with more mature supply chains, the fuel flexibility may not be quite as critical. And those aren't just things that affect individual technologies or fuels. They'll also vary regionally as well. So it's something to think about, depending on where your operation is. Is the supply chain mature in that area? And so do you need flexibility in the future? And if you're looking at resale assets, resale of assets in the future and resale values, do you need the flexibility to move that asset geographically when you're disposing of it? So there's a lot of questions to ask about the supply chain, and there's a lot of thinking to do about what makes sense in terms of the efficiency and what the economic drivers for that are. But I think it's both the efficiency and the fuel flexibility are something that's going to become increasingly important heading towards 2030.
It's a bit of a minefield, is it not? If you're a ship owner or an operator. Mark, you mentioned earlier some of the options that you've looked at and that you think are viable and work, but you know, how long does it take to get to a point where you feel like you've got some of the combination of factors? I mean, what is actually available today? And then it's hard, is it not, when you're thinking about blue fuels and green fuels and what's available now and what's going to be available or not further down the line, and the timelines and is it finger in the air stuff to a degree? Or, I mean, how do you go about that?
I was at COP26 in Glasgow 2 weeks ago, and one of the workshops that I was attending, one of the representatives there talked about ammonia, and I was really encouraged by, you know, sort of one of the more environmentally active parties there talking about the safety considerations of ammonia. And I do think that that's something that sits very high on my agenda. And at the moment, I'm relatively uncomfortable with coming to terms with the safety aspect of ammonia. And we hear a lot of language around ammonia-ready vessels. And based on the conversations I've had and the reviews that I've done so far, I'm not entirely sure that there's as much substance behind that as we might be led to believe sometimes, at least in terms of what the shipyards are putting forward as an ammonia-ready construct. Certainly, again, specifically related to the safety concerns. And one of the points that was made, and I don't have the report to validate it, but there was a question posed around the grounding of the Wakashio in Mauritius and modeling that kind of accident using an ammonia-based fuel, and what kind of damage would have been done. Because let's be honest, when ships do have accidents today, fuel does spill. So either we're going to become so fully insulated on a vessel that we can guarantee that there never will be a spill of such a type of fuel. And that's a concern for me. What I do, however, like is the concept of methanol, because I do feel that methanol is available around the world. I think methanol is already a commodity that is transported reasonably easily. Yes, it is a low flashpoint fuel, and that we have to be aware of and considerate of. But I think in terms of training for crews and overall experience that we have with methanol and the global availability of it, there's a lot more opportunity associated with that. I also think that when you're talking about something like methanol, we have to talk reciprocating engine versus fuel cells. And this is where I come back to the point I was making earlier around diesel generators. We are not going to solve this problem by immediately jumping into the main engine and saying, how are we going to propel a 25,000 TEU container vessel at 20 knots halfway around the world? Starting it from that point of view will become the endless debate that will never be solved in this time frame that we're talking about, at least from a ship owner's confidence point of view. But starting with the diesel generator, starting to look at fuel cells, looking at methanol as an option, you're starting to get a sense that there is some reality that can be put into this shorter time frame. You can price methanol out and look at it on the futures basis and start to put some real numbers behind this. So in my world, it's not so much a question of finger in the air. There are some options that are out there. You just need to be prepared.
Thank you. I'd like to bring Sebastiaan in here, actually. Sebastiaan,
Sure.
Thinking about what Mark's saying, thinking about making investments now, thinking about the technology, how adaptable is the technology in terms of, can I invest in something now, but be confident that actually it can be adapted to potentially go in a slightly different direction without costing the earth?
What I tend to say about this is that if you look at technology on board vessels, and if you look at engines, so main engines and not generator sets, those tend to not be the issue. So the basic concept of an engine that we have today will also be suitable to run on ammonia or methanol or methane, LNG, within a relatively short time frame. The bigger issue usually is how do you store that fuel on board? Where do you store it? In what volumes? How do you do that safely? As Mark said, I mean, the safety of ammonia as a fuel is a definite concern. This is something we need to address as an industry. So I tend to worry more about the fuel storage on board. than actually the prime movers itself. The prime movers you can either convert with engines, or maybe even change, or at least do something with some reasonable amount of it's doable. Let's just put it that way. Whereas adding an additional fuel storage system is a whole different kettle of fish. So that's typically where the problems start to arise. Do you actually have the space? Is the ship layout, is it suitable for also for the mass of that additional maybe fuel storage system that you're adding? How does it all fit together? Is the fuel storage volume sufficient to actually provide the amount of energy you need for the operation you want to run, or do you need to make changes in your operation as well, because you can actually carry less, well, maybe not less volume or less mass of fuel, but less energy. So I tend to worry more about the fuel storage than the conversion of fuel into mechanical energy.
Makes sense. And David, so on that, from a vessel design perspective, you're well placed to continue on from Sebastian's train of thought there, if you will.
Yeah, so there's a few points to pick up there. And Sebastian's right. Looking at the prime movers involved, the sizes and overall weights and centers of those are not likely to change significantly, but the storage is, and that's another reason, going back to Mark's point about low-hanging fruit, things that may be the first to change on board ships will be the auxiliaries, because the fuel consumed by the auxiliaries is much less, and therefore adapting existing vessels to take alternative fuels for the auxiliaries is an easier task than the main propulsion, and maybe something that owners want to start with in order to de-risk that transition, rather than to make a single bold step, is to do that in a managed way. In terms of how that impacts the vessel design, we need to think about how ships are going to look in the future for new builds. Are ships likely to get bigger? Because we know that the alternative fuels have a lower energy density, so they take up more volume, more mass for the ship. Or are ships likely to stay the same and have larger fuel carrying capacity, which would obviously mean a lower cargo carrying capacity, and that obviously changes the kind of economics of operating a ship. In terms of how you plan for that going forward, adding significant volume for storage is obviously a challenge. It doesn't mean that it's impossible, and there are things that you can look at in vessel designs to make it easier to retrofit those technologies or increase storage capacities on board. But it's all about thinking what that step will be, and what is the route, and understanding where that's likely to go. And obviously part of that is looking at what the likely alternatives are. And Mark's mentioned a couple of the alternatives already. There are a few others, and I think depending on the type of operation, where in the world the ships are, what kind of distances they're transiting, different solutions are likely to be the most economical or fit the profile, and therefore there probably isn't going to be a one solution going forward for all types of operators. Safety is another point that was raised, but it's not just the safety and how you technically manage that. In industry, there are plenty of chemicals and fossil fuels that have hazards associated with them that we manage through technical processes. But it's also about the perception of those. So certainly for passenger ships, if there's a public perception of risk, then that's going to be, that needs to be managed on a passenger vessel, because you need to persuade people to get on board the ship. But the same goes with other vessel types. If you have charterers, there you need to understand what the perception is, as well as what the technical risks are, and make sure that you have plans and strategies in place, really.
Chester, just if you can talk a little bit, following on from what David's just said there, but thinking about adaptability and adaptable vessel design, and there was very much a horses for courses message there, which again goes back to the underlying point that there is no, I've seen that so many times, there is no silver bullet, there is no one size fits all. So I suppose that's why we're having this webinar, in terms of how do you work out what's right for your particular vessel?
Yeah, and we're having the webinar because it's not an easy question, but I mean, coming at this from a consultant's perspective, it's about, but it's making decisions within uncertainty. And I think the things that you can start doing to start making those decisions in uncertainty is picking off the certainties or the least risky bits that you can do within that. So I think a lot of building a strategy from my point of view, in terms of how to remain flexible and not get to a future fuel dead end, is about really, well, one, gaining quite a lot of information on sort of the operation of a fleet or a particular vessel, how it works, locations, geographies, what it is actually required to do, against what it's currently it can do on paper. So that there's these things about, do you increase the size of your storage to get the same storage as you do today, or are you actually not using all the fuel within the tanks? So you start getting into the questions like that. I think what David was starting to touch on there around some of the flexibility requirements is really important. So I think you can do this sort of theoretical exercise with the information and the data that I was talking about to start to produce that strategy, but then there's still going to be some uncertainties that you can't answer. You can answer the ones that are fairly low risk, but there's still stuff that you can't answer, and that's where flexibility, in my mind, comes into this. And there's no quick answer to this, but it is really on a sort of vessel fleet level about flexibility, and it could be, okay, this vessel looks like, given its age and stuff like that, if we were going to procure a new one, it may be methanol, it may be ammonia, but the technology isn't there yet. So what we need to do is design that vessel in such a way that we can retrofit that fairly easily to what we need in the future. And Sebastian's already said that the engine part of that isn't the most difficult, but it's still a challenge to surmount. But when you're thinking about, if it's methanol, having the correct design on board to be able to meet regulations that already exist for low ignition point fuels, for example, double wall piping, extra space, bringing all these things into your thinking and the strategy of how you move forward, I think is really important. So it's not unfortunately, it's not the easy answer. I'm not saying that we have that silver bullet solution that you're going to get off an hour-long webinar with us today, but it's really delving into the detail and starting from those things that that are certain, and then building flexibility around that. I think that's the best way I can answer that question.
Mark, just to bring you back in there, in terms of existing vessels, but then also with an eye on the future as well. Give us a flavour of where you're at and how far you've progressed. And I'm guessing there's still a lot more to be done. I mean, the fun never stops, I'm guessing.
Yeah, I think, we run up against a fundamental problem of who pays for the fuel. And we've got to understand the commercial nature of shipping, and understand that in the typical liner trades, They're all on long-term time charters, and therefore it's a function of what the charterer is prepared to do and pay. So it's not a owner-driven singular decision in that respect. That's not the market that I'm in. I'm in the tramp trades. So to some extent, those big consumers that are in the liner trades and the container fleets, with the fundamentally different drivers that they have, they're going to be dictating the infrastructure that's going to be there to supply when the charterers are at the table with them saying, this is what we're prepared to pay and this is what we're prepared to incentivize, or whatever way around that goes. So tramp trades are, fundamentally a different operation. And I think you can't afford to be Puritan about this and say that, one strategy is right, one strategy is wrong. Each will be arriving at their conclusion by different means. The important thing is that you arrive at some form of conclusion, and you can't just be saying, well, I'll sit on the fence until 2028. That's not a very good strategy, and neither is luck a very good strategy. So, in our world, we will be trying a fuel cell, hopefully next year. We will be looking at a way that we can operate that fuel cell through a methanol reformer, simply because we know that hydrogen is the end point that many of us are going to be looking for in one form or another. I come back to the fact that it is about diesel generators in the short term, looking at ways that we can do that, looking at ways that we can improve the operation. Here's a fundamental problem with ships. They're built for a design speed that is nowhere near the operating profile. So a ship, when you go to a shipyard, is built for a 14.5 knot trade that, to be quite honest, we never do 14.5 knots, even, if there was such a thing as a good market. So the design speed of a ship is a fictitious point, and the design draft of a ship is a fictitious point as well. So ships are not built really, truly to an optimal number that is in any way related to the way that we operate them. We got to go back and look at that as a starting point, and that's bringing the shipyards into the discussion. If you think about a ship being built for this design speed of 14.5 knots, all of the equipment on the ship is designed to allow that ship to operate at 14.5 knots. So that means the engine room fans are either on or off. Simple as that. And the engine room fans, when they're on to supply enough air into the engine room to give you the consumption at 14.5 knots. Ridiculous. All the pumps are spinning around, pumping water around, sufficient for 14.5 knots. Ridiculous. So the whole idea about a ship's construction has to come back into understanding that we don't want design speeds at 14.5 knots. We want flexibility of engine room fans to be slowed down. We want pumps to be slowed down. We want the electrical load to be reduced. If the electrical load is reduced, we can start to put equipment on that no longer needs to have 650 kilowatts of power. Maybe we could get down to 400 kilowatts of power. Better fuel consumption, better emissions, better everything to do with the ship. So this challenge sounds pretty easy, but you've actually really got to go back and start thinking about some of the very basic things about how a ship is designed.
I can see lots of nodding heads. Sebastiaan, you seem to be wholeheartedly agreeing with Mark there.
Mark is right on the money here. I mean, if you look at what Mark's just described, it is the most intelligent thing in the world to do, right? To design a ship to have a design speed at 14.5 knots. Then we add a bit of margin on top for this, a bit of margin on top of that, and then we run the entire thing at 9 knots, 10 knots, maybe something like that, Mark. And you use a lot less power than what you have installed, causing all of the other equipment indeed to run at sort of a suboptimal point. And then if you think back to our discussion about efficiency just 20 minutes ago, what happens then on such a ship if you bring in, for instance, wind propulsion? So what happens if you have an MR tanker, like Mark, I know you have quite a few. What happens if you install either sails or a towing kite system or something like that, or flatbed rotors? which drives the operational points of all the onboard equipment down even further. You end up with something which is very, very, very sub-optimized towards what it is actually doing. So I wholeheartedly agree with Mark that we need to look at what's the actual operation that we expect for the vessel. We may be wrong, but we can surely do better than what we do today and design just simply for 14.5 knots and then see what happens afterwards.
David, do you believe that there's widespread acknowledgement and agreement of this? Is change happening?
Yes, I think so. And obviously in those type of vessels that have the biggest hotel load demands are probably at the forefront of this change. But it's not just about the auxiliary loads, which obviously are important. But if you start to operate vessels at lower speeds than the original design intent, that also affects your hull form that you're testing at the very outset. And whilst the auxiliaries are probably the low-hanging fruit, and possibly a good place to start, speed is probably number two. So looking at reducing speed, we already know that's a good way of reducing fuel consumption. It's a good way for operators to reduce their overheads and their costs associated with fuel. With EEXI coming in, it's one way of complying with new regulations with kind of the minimum amount of technical changes is looking at slow steaming. But if that is the route that you're going for future hulls, and this probably isn't so much a retrofit thing, but with future hulls, being clear about what the speed that you actually need and are actually operating at is key, because the hull forms will be optimized and designed around that speed. So if you have a hull form designed for 14.5 knots, it won't be performing as well at 9 or 10 knots as it could do if it had been optimized for that speed. And the really important thing here is that the power required to get the ship to those speeds is, it's an order of magnitude more than the auxiliaries. So even very small efficiency gains in the hull form can give you quite big benefits. And all of this, again, going back to the point that was made at the very start, I think by Sebastiaan, this all needs to be looked through the lens of the economics of alternative fuels and the fact that they're likely to be more expensive, and also the technical properties of those fuels, that they are taking up more volume and more mass on the ship. So anything that you can do to get those volumes down is good and leaves you more weight and space for cargo and for the ship ultimately to earn money.
Absolutely. And I think before we sort of open to the floor, if you like, the proverbial floor, and take questions from the webinar attendees, it sounds like the most important thing here is it's not that any one person has all the answers, but what's important is being able to ask the right questions. So I'd really like to just turn to each of you and, to briefly share your thoughts in terms of what are the key questions that, we should be asking, or ship owners should be asking themselves when they're creating a strategy for 2030 and their vessel or their fleets. Mark, may I start with you?
Yeah. So again, I'll come back with as practical an answer as I can. Quite simply, in a new build construct, why do you need to have 3 diesel generators on a ship? Class only requires you to have 2. So we put 3 on because one spare is a pretty good idea. So why don't we build ships with 2 of Sebastiaan's great engines as that, and have the 3rd generator as being an alternative form of come back to it again, electrical generation. I sound like a stuck record, but there's a logic here, right? You don't need to spend the capital in building a ship now with 3 full diesel generator plants. You can offset the capital cost by putting an alternative form of energy device on board a ship for the electrical propulsion. That makes good sense. That's a starting point where you still have the backup of a diesel generator, but you can look at alternative forms. And I think that kind of thinking has to be brought in pretty soon into the shipyards. Problem is, I don't really hear a lot of webinars with the big shipyards on it coming in and telling us what they're planning to do with this. And I think they're a little bit absent from the conversation.
Sounds like a future webinar in the making, Mark. Thank you. Sebastiaan, same question to you. What are the questions that should be asked?
I'm going to go one step further than Mark here and say that I think the main question that should be asked is, what do I actually want to do with this ship? What is its intended operation? And you start from there. We've just heard from David. If you go into this optimization routine of looking, what speeds do I actually need to do? How much fuel do I need for this? What kind of power plant am I going to use for this? Can we use something more compact? So instead of having one big main engine and 3 auxiliaries, let's look at concepts where you can actually have modular, maybe medium speed engines driving the entire ship. So you have a smaller engine room, you have more space, so you have a higher utility for the vessel. You've got more space for cargo. And you can all do that if you look at what do I actually need to do with the ship. It doesn't need to go at 14.5 knots. What if I design it actually for its intended operation? I think that's one of the key questions that we need to ask. And then also, what's my appetite for risk? How is the trade-off between de-risking the vessel by adding flexibility, which costs? I mean, let's not kid ourselves. This isn't for free. Versus what kind of risk mitigation do I actually achieve with that? And how is that cost-benefit ratio for me? Do I feel comfortable with that? Sorry, 2 questions.
No, that's good and nice and concisely delivered. So even better. Chester, same to you. What question or questions do you believe should be asked?
I think Sebastiaan took my first one. That's the danger of these webinars. But I think the thing that I would add from my perspective is the questions I'd be asking is, what can I do, and what can I do in the short term? What are the low hanging fruit? What can I do before 2030? What's the composition of my fleet, and what are the options there? But I think the thing that hasn't been mentioned yet is really that view to the future, which is, what do I need to have? What information do I need to have, and what exposure and what conversations do I need to be engaged in to be able to reach those sort of further off targets and really hit that deep decarbonization area? So we're in an unfortunate position where the sector has very little time to do an awful lot of things. So I think moving forward on those 2 fronts would be my sort of summary of it. What's the short term, and what do I need to inform that long term?
Which means, David, you've really got the difficult end of the stick now, because hopefully everyone else hasn't taken all the questions that you believe should be asked.
I think they may have. So I think understanding going forward with looking at alternative fuels, understanding what your options are. So what fuel options do you have? And is doing nothing an option? And I don't believe that is. But once you understand what the options, what the alternatives are out there, what will your ship look like in the future? And that will be a different answer depending on where you operate in the world and what your ship's doing. But what will the ship look like? How will it operate in the future? What will your speed be? What range do you really need to do? We've lived through an age where diesel is a really nice fuel. It allows us to carry far more fuel and far more energy than we really need, and so we can bunker for convenience rather than for necessity. Are we still going to do that? Is that still going to make economic sense going forward? But crucially, and I'm probably reiterating Mark's point here, is what can I do today to test these? How can I de-risk this going forward? What can I look at on existing vessels to test technology? What do I need to put in place for any longer term new build strategy going forward? But I think it is about what you do today, because as Mark pointed out at the very beginning, 2030 is not that far away.
It's not. It's getting closer by the minute. We have got some questions coming through, which is good. And please, if you're listening in and watching in, please do submit your questions through the Q&A function. Hopefully it's very self-evident. Love to hear sort of what you're thinking, your reactions to what's been said, and any questions either for all of the panelists or indeed for somebody in particular. Just let us know. So one of the questions we've got here: can we say that certain fuels are more suitable for specific segments? So, for example, are bulkers likely to adopt methanol, container ships more suitable for ammonia, whatever it might be? Anyone volunteer to give some thoughts on that first question? Sebastiaan, you are already unmuted, which is a definite raise of a hand for me.
It's especially if you look at ammonia, I have a hard time imagining passenger ships running on ammonia because of A, the safety concerns, and B, also possible smell issues. Let's just call it that. Okay. And then just to carry on from this, it a lot of this also depends on the capex versus opex balance. So it depends if you're for instance a liner, and the capex and the opex land on the same table, so you can actually make this informed decision. Do I spend more on the technology to be able to utilize a cheaper fuel, or do I optimize towards either one end of the scale, lower capex operation, or lower opex operation? That may have an impact. Mark has something to say on this, I think, right?
Of course, Mark has something to say. I mean, Mark, please do answer. But what I'm also interested to hear from you is you obviously in your segment have a view, but I wonder also, do you believe that the route that the direction you're taking is actually sort of also being followed, adopted by others within that segment?
Yeah, it's interesting. I mean, look, it's no secret that we did at the beginning of this year invest in some technology as a part owner in methanol reformation. And, obviously the homework that we did around that was to try and establish what is the efficiency specifically of methanol, remembering that it is hydrogen that we're trying to get to. One of the things that, I was greatly impressed to learn is that methanol loves water like gin loves tonic. And, what has water got? But it's got 2 free hydrogen atoms in there. So if you can mix methanol and water and come up with a fuel that is 1/3 water from which you can yield the hydrogen, you've suddenly got a very, very impressive fuel source that is available, as I said earlier, around the world. So I think as people start to understand some of the chemistry that's behind this, and to be honest, it took me a little while and bit of going back to my high school chemistry books to really start to understand this. But the people who are involved in these technologies have been involved in it for years. And, we think that this is new to the market. It's not. These technologies have been around a long time. They're just coming to perfection now. And perfection is, a word that I use lightly, meaning that adaptation, perfection in terms of being able to adapt it to our environment. It's certainly not the end game. And I think that what we're seeing is probably the beginnings of the old mobile phone, where we're going to be carrying maybe a bit of a brick around behind us as the battery to enable our technologies to be applied, and they will be developed between 2030 and 2050. But we can start now. There are good options out there. You've just got to do a heck of a lot of homework. And as the guy said earlier, there is a risk appetite associated with that. But that's no excuse not to do your homework.
Thank you. David, I don't know whether you or Chester want to chip in on that.
Just going back to the different vessels and different fuels, I think, absolutely there will be different types. And I think you need to look at not just the economics, but also the technical challenges. There are certain vessel types that will need to pay a premium for some of the more advanced fuels that have the energy density that's comparable to diesel. So I'm thinking of high-speed passenger craft, for example. There isn't really the technical scope for those to carry the dead weight needed to run on some of the other alternatives. So they're likely to be at the premium end of the alternative fuels. The difficulty at the other end of the scale with intercontinental trades and things is having that supply chain that's global. So the regions that vessels operate in is key as well, because it's okay finding a secure supply chain if you're running a Ropax ferry across the Med or the North Sea, and you know which ports you're bunkering in. But if you're trading globally, particularly if you're trading on the spot market, and so that you're not always going to the same ports, you need to have a larger global infrastructure to support it, and that's where some of the other alternative fuels have advantages. They may not be infrastructure that's designed as a fuel, but it's infrastructure trading that commodity. So yeah, and that goes some way to kind of clarifying it.
Thank you. Sebastiaan, there's 2 questions here for you. Lucky you. How can we accurately measure efficiencies from different energy-saving devices? And can we expect technical advances to change some solutions over the coming sort of 5 to 7 years? PEM fuel cells, new battery chemistries. Let's go. How can we accurately measure? Let's go
exactly.
for one.
Let's take those one at a time. I'm struggling with the second one.
Yeah. Well, let's go with the first. How can we accurately measure efficiencies from different energy-saving devices?
Data. It simply comes down to acquiring the critical data on, for instance, fuel consumption, and processing that in an appropriate way, either through using digital twin technology, i.e. what would the ship have done without that technology on board, and then comparing it what the ship actually does in operation, which again means that you need to have a very good handle on what are you actually doing, where are you operating, under which conditions, and what is my fuel consumption. But data would be the answer here to figuring out how much a certain energy saving technology actually saves you. There are, of course, also certain energy saving technologies which you can simply turn on and off. Air lubrication, for instance, being an example. Those are easier, of course, to get a handle on what the operational benefit is. But for the technology that you cannot simply turn on or off, or put on or take off of the vessel, data is the answer. What was the second question, Amie?
Can we expect technical advances to change some solutions over the coming 5 to 7 years? And the examples given were PEM fuel cells, new battery chemistries, etc.
Okay, so I think this is about fuel cells, PEM fuel cells, and then batteries. And for PEM fuel cells, I think we know relatively well what the operational efficiency is, what the technology perspective is, and from my perspective, the challenge there is more towards scaling and integration. How do we efficiently and in a cost-efficient manner as well scale up the PEM fuel cells to a size that is reasonable and usable also on board of ships. And for battery technology, I mean, we will tag along with what is happening with on-road mobility, electric cars, and also energy storage on land. And we will see definite increases in energy density, but also charge and discharge rates that are allowable for batteries. So if you use those batteries in a hybrid system, and if you are now limited by the amount of power you can put in and take out, so the charge and the discharge rate, that should also increase in the few years to come. By how much? That's anyone's guess, of course.
Thank you. There's a question here about what's your take on cold ironing or shore connection if we talk about, pull my earphones out, auxiliaries and other equipment. Chester.
I'm happy just to come in quickly on this and say I think absolutely cold ironing, from my point of view, has to be a given now for ports in the industry. I think it's got lots of challenges that I don't want to go into now given the time, but I think that it is a very efficient way to run things whilst you're in ports. And I think absolutely I agree with some of the regulation that's coming in about mandating that as a thing for the future in ports. So slightly controversial in some circles, but a direct link up to electricity is, well, especially when that's green electricity, is definitely the most efficient way to reach carbon targets in that respect. So I'm fully supportive of that, but there's a whole world of other issues out there, mainly around the main propulsion, that need to be addressed. Cold ironing and the use of auxiliary systems in port is a very small piece of the pie, as David alluded to earlier.
Anyone else, any thoughts on that before I move on to the next question?
Could I?
Please, Sebastiaan, please do.
So I think the key thing that Chester said here about shore power is as long as it's powered by green electricity. And that, unfortunately, is not a given. So for ships with smaller amounts of auxiliary power need, that should more or less be okay. They are a smaller additional and marginal load on the local grid in the port. If you think, however, about, take the example of a cruise ship coming to the Bahamas, and all of a sudden adding 10 megawatts of auxiliary load to that local grid. So you really need to think about this from a system perspective, taking also the energy generation locally on in mind, because you may improve things in port, but you may actually create a bigger problem further down the road. So as long indeed as it's powered by green electricity, definitely. But you need to have the flexibility in that grid to also enable the amount of renewable electricity that you need to be available in that grid. Otherwise, we're just trading one problem for another.
Yeah, I'm David. Briefly, please.
I was just one line, but of course, to have that flexibility, the vessels need to have the equipment.
Absolutely.
Wow, that was very. I asked
Very
for brief
quick.
and I got brief. When does that happen? Wonderful. I'm just very conscious of time. I think there's one sort of final question here that does link back to what you were talking about within the discussion, but it is important because I think it's about change and progress. So great point raised about designing and building ships to the actual variable operating conditions and speed. How does that translate into contractual tests and trial requirements, and who drives this process change? I don't know who would like to. David, go ahead.
I would say that the owners of vessels drive that. They're the ones that will set out what trials they want a shipyard to demonstrate to them to accept the vessel. So it's about owners asking the questions of shipyards. I think if we sit back and wait for shipyards to offer answers to these problems, we could be waiting a long time. So I think the owners need to drive the answers from the shipyards, because, as I said, the answers for different operators will be different depending on where they are in the world, what their economic drivers are, what their supply chain looks like. And shipyards supply ships to all sorts of different owners, so they won't really be in a position to offer a single solution to all of their clients. And so I think it really sits with the owners to drive that.
Mark?
Yeah, building ships in Korea isn't as easy as perhaps it sounds, to go into the shipyard and go, hey, by the way, this is what I want, give it to me. It doesn't currently work like that. So we really do need the big shipyards to be in here talking about a new way of approaching this problem more collaboratively than perhaps what they have in the past. And it's very much been, here's a ship, if you want it, take it. If you want to modify it, that's going to cost you a bit of money. We can't afford to be in that relationship anymore.
Thank you. Just Sebastiaan, sort of a few final thoughts.
Definitely agree with what Mark just said, where we're currently in a situation where, well, if you want something different than standard, that's going to be expensive. And that definitely hampers the take-up of new technology and also flexibility. So it in a way, it keeps us away from hitting the targets that we need to hit. And we need to start today, basically.
Chester, just some concluding comments, if you will.
Sure, I agree with everything that's just been said. I think there's been a lot of agreement on the call. I think there's areas that we didn't go into as much depth on in this call. As I saw a couple of questions on sort of sustainability and the sustainable availability of fuels, particularly. So just my final comments, I think, will be linking back to sort of the context setting that I put earlier, is that with all these fuels that we're talking about, there's different ways to make them, and those different ways from different feedstocks and different conversion technologies, and each of those has different economics and different sustainability characteristics. So just I think that the importance of including that in any thinking is really important.
Thank you. And then very, very final and concluding comments from you, David, before we wrap up.
I'd just like to say that if we look back to previous fuels used in shipping, ships looked very different to the diesel ships that we have today. And so looking forward with alternative fuels, the ships of tomorrow are likely to look different. And I think the question now that needs to be answered is how are they going to look different? How are they going to operate differently? And how do I start my journey towards that?
Thank you. I'd just like to thank all of you, David, Mark, Sebastiaan, Chester, for answering everybody's questions and for hopefully giving some actual tangible advice that people can take away with them. I mean, it sounds like the difficulty is it needs a change of mindset. We need to challenge the status quo and we need to think laterally. But I think if we're going to achieve, as Mark, you pointed out at the very beginning, the right balance between the ecological and the economical, then ultimately it sounds like it's about asking the right questions as a starting point. Thank you so much, everyone.